What do you mean by three-point problem? Explain several methods for solution of that problem.
Answer: locating the plotted position of a station point using observations to three well-defined points whose positions had already been plotted on the map is called solving three-point problem. Three-point problem is related to resection method of plane tabling. A. Trial and error method. This is the simplest method for solving the three-point problem and used when the accuracy requirements are not very high. In this method, the surveyor first determines the position of the unknown point and then measures the distances and directions to the two known points. If these distances and directions are not satisfied, then the position of the unknown point is adjusted until they are satisfied. B. Mechanical method. This method is more accurate than the trial and error method, but it is time-consuming. In this method, first of all, C. Graphical method. This method is also known as Bessel's method, is the most accurate method for solving the three-point problem. It is based on the inscribed quadrilateral property. In this method, first draws a circle with one of the known points as the center and the distance between the two known points as the radius. The other known point is then used to draw two intersecting arcs on the circle. The intersection of the arcs gives the location of the unknown point. D. Analytical method. This method uses trigonometrical properties to solve the three-point problem. In this method, the coordinates of the unknown point are calculated using the known coordinates. 2. Write down the various ingredients and the physical properties of the cement. Answer: the various ingredients used in cement are lime, 60% to 65%, silica, 17% to 25%, alumina, 3% to 8%, iron oxide, 0.5% to 6%, magnesium oxide, 0.5% to 4%, sulfur trioxide, 1% to 2%, alkalis, 0.5% to 1%. Physical properties of the cement. The various physical properties, which directly affects the strength of the cement, are as follows. Fineness. The fineness of cement is a measure of the particle size distribution. The finer the cement, the greater the surface area and the more reactive it is, and hence, finer cement will set and harden faster, giving higher strength. Soundness. Soundness is the property of cement to retain its volume when it is mixed with water and allowed to set. Unsound cement may shrink or swell, which can cause cracks in. C. Consistency. The consistency of cement is a measure of its ability to flow. The more consistent the cement, the easier it is to mix and apply. Strength. It is a measure of ability of the cement to resist forces such as compression, tension, and flexure. The higher the strength of cement, the stronger the concrete or mortar will be. D. Setting time. Cement has initial and final setting times. The initial setting time is the time it takes for the cement paste to start stiffening, while the final setting time is when it becomes hard and resists penetration. The setting time is important because it determines how long the concrete or mortar can be worked before it hardens. E. Heat of hydration. It is the heat released when cement reacts with water. The heat of hydration can cause problems if it is too high, such as cracking the concrete or mortar. F. Bulk density. It is the weight of cement per unit volume. The bulk density of cement is important because it affects the amount of cement that is needed to make concrete or mortar. G. Specific gravity. The specific gravity of cement is the ratio of its density to the density of. C. Consistency. The consistency of 4. Briefly describe the discharge measurement method through notches. Answer. A notch is a device used for measuring the rate of flow of a liquid through a small channel or a tank. It may be defined as an opening in the side of a tank or a small channel in such a way that the liquid surface in the tank or channel is below the top edge of the opening. It is made from metallic plate and is smaller in size. The discharge measurement method by using notches is a simple and accurate way to measure the flow rate of water in a channel. Rectangular, trapezoidal as well as triangular shaped notch are used for discharge measurement. It is based on the principle that the discharge over a notch is proportional to the square root of the head of water above the notch. Following steps are taken to measure the discharge of water using a notch. The notch is installed in the bottom of the channel. The water level in the channel is raised until the desired head is achieved. Water level at upstream of the notch is measured by using a level gauge. The recorded water level and the notch-specific equation is used to calculate the discharge rate. This equation typically relates the head, the geometry of the notch, and a coefficient. Five. What are the factors that affect compaction of soil? Illustrate the relation between compaction and optimum moisture content. Compaction of soil is the process of increasing the density of soil by reducing its voids by mechanical means. The compaction of soil improves the various engineering properties, such as increasing its strength and bearing capacity, stability, drainage properties, and reducing permeability, settlement, erosion, etc. Various factors that affect compaction of soil are moisture content. Moisture content of the soil is an important factor. The maximum dry density of soil occurs at an optimum moisture content. If the soil is too dry, it will not be able to be compacted properly. If the soil is too wet, it will be difficult to compact and will not have the desired strength, amount of compaction. The compaction effort is the amount of energy applied to the soil to compact it. The compaction effort can be increased by using a heavier roller or by applying more passes with the roller. Method of compaction. The method of compaction can also affect the degree of compaction achieved. Some methods, such as static compaction, relation between compaction and optimum moisture content. The moisture content of the soil is an important factor. If the soil is too dry, it will not able to be compacted properly. If the soil is too wet, it will be difficult to compact and will not have the desired strength. When moisture of dry soil increased slowly, then soil particles get lubricated and bounded together, and due to which it becomes easy to compact the soil particles. As shown in figure below, the density of compacted soil increased accordingly with increasing water content up to a point, and after that point, dry density starts decreasing as moisture content increased again. This point is known as optimum moisture content, OMC. The maximum dry density of soil occurs at an optimum moisture content. Beyond the optimum moisture content, further increases in moisture will cause the dry density to decrease because excessive moisture creates a slurry-like consistency that hinders particle packing. Hence, it is important to compact soil at the optimum moisture content to achieve the desired results. 6. What is development length? What are the methods for achieving development length? Answer. Development length, also known as anchorage length, is the minimum length of reinforcement bars that must be embedded and anchored within a concrete structure to transfer loads from the steel to the concrete effectively. The embedded length of reinforcement creates a safe bond between reinforcement surface and concrete and ensures that during ultimate load conditions, the reinforcement bar should not slip out from the concrete due to joint slippage. The development length required depends on following factors: the grade of concrete, the grade of steel, the diameter of the reinforcement, the type of loading, tension or compression, the location of the reinforcement in the concrete member. The development length can be calculated by using following formula: LD equals ST for BD. 1. Where LD equals embedded. Some common methods for providing development length are: A. Standard hooks. It is common methods in which rebar is bent at the ends into a standard hook shape. These hooks are then embedded within the concrete at a certain depth to ensure adequate anchorage. The specific hook dimensions and angles are typically defined by design codes and standards. B. Straight bars. In some cases, straight bars are used without hooks where bars are extended into the concrete to achieve the required development length. The length is determined based on structural calculations and codes. C. Lap splicing. When the required development length exceeds the available length of a single rebar, lap splicing is used.